Solve the inequality. If a solution exists, write it using interval notation. Use a single interval if possible. We have here the absolute value of something, absolute value of 2x plus 5, greater than or equal to 5. This absolute value sign, you'll recall, tells me that I have to take whatever's inside of it and make sure that it's a positive thing. Right? So if 2x plus 5 happens to be positive, if 2x plus 5 is greater than 0, or maybe equal to 0, then this absolute value sign gets rewritten by just erasing it, not commenting about it at all, right? If the thing inside here is positive, then absolute value signs don't have to do any work to make it a positive thing. So we just get to erase them. So if 2x plus 5 is positive, here's how we rewrite that. If, on the other hand, 2x plus 5 is negative, so 2x plus 5 less than 0, or maybe equal to 0, then this thing inside the absolute value signs is a negative thing. And I'd like to take and turn that negative thing into a positive thing. So I'll go ahead and do that. If I take a negative thing and take the opposite of it, multiply it by a -1, take a negative thing and take the opposite of it, then all of a sudden I have a positive thing. So this is how to rewrite absolute value of 2x plus 5 if 2x plus 5 is negative. So here's absolute value of 2x plus 5, that's greater than or equal to 5. Small word of warning here. Some people will say, oh look, you multiplied by a negative number, we have to switch the directions of our inequalities. That's not true, because I did not multiply both sides of the inequality by -1. All I was doing was rewriting those absolute value signs into a different form, similar to if I take a number 2 at some point and decide that I'd like to rewrite it as 1 plus 1. I'm not adding 1 to both sides of anything. I just rewrote the way that I'm representing 2. Similar here. I'm not multiplying both sides of anything by a negative. I'm just rewriting the way that I'm representing this absolute value signs. Okay? So this was not multiplying by -1 on both sides of the inequality. I don't have to change directions, but now that we've done that, let's go ahead and actually do multiply both sides of this inequality by a negative number. That way I don't have this negative out front there, so I can just write 2x plus 5. If I multiply 5 by a negative, I get -5. Now I did multiply by a negative number, so I have to switch directions to my inequality. It's at this point that we can see where the real neat thing about these absolute value signs and the greater than happens. And the neat thing is this. If we happen to have a solution of 2x plus 5 greater than or equal to 5, then 2x plus 5 being greater than 5 is also greater than 0. So anytime this condition is met, this condition gets met for free. Similarly, if we have 2x plus 5 less than or equal to a -5, then 2x plus 5 is also certainly less than 0. After all, it's even smaller than that. It's less than -5. So this condition is going to get met for free as long as that's met. So we don't have 1, 2, 3, 4 conditions that we're talking about. We really just have 2. This one or that one. If this one is met, then 2x plus 5 is positive, and we rewrote this absolute value signs correctly. So if this was met, then we have a solution to this equation, this inequality. Similarly, if this inequality is met, then 2x plus 5 is a negative number, and so the way to rewrite this is that way. So if we had a solution to this, we also have a solution to the original inequality. So a solution here or a solution there is a solution to our question. The word or, that tells us we're thinking about a union, right? So if I find all the solutions to this first set and all the solutions to the second set and take a union of them, that's the solution to my original inequality. So let's go ahead and do that. On this side, let's subtract 5 from both sides. So we get 2x greater than or equal to 5 minus 5 is 0. Divide both sides by 2. X greater than or equal to 0. X greater than or equal to 0. That's everything from 0 out to infinity, right? And I get to include 0 because of this greater than or equal to. 2x plus 5 less than -5. Let's subtract 5 from both sides. -5 minus 5 is -10. Divide both sides by 2. I get x less than or equal to -5. What's everything less than or equal to -5? That's negative infinity out to -5. Include -5. I'll take a union of those two sets. And this is the answer to my original question.